If you guys can, remember to go take attendance, on the attendance question. See, I've been meaning to ask you because I forgot. I've had two people that says this happens to them so far. If you guys switch away from the tab that has Zoom on it and then go back to the Zoom tab, do you lose your video and everything? Or is that just kind of a couple random people? Oh, yeah, that true. I guess I'm wondering if it's the Chromebooks more than anything. Well, that's kind of what I got up to. Okay. Well, let's kind of continue on in this unit. For the most part, my goal is to be pretty much done with the unit by Friday if we can. And then that would kind of leave us all next week. We don't have school Monday because I believe that's Martin Luther King Jr. Day. Yep. So next week we have school on Tuesday, Wednesday, and Thursday. Thursday is the last day of the trimester. And so my kind of intention was to take the test either Wednesday or Thursday, and I'll kind of leave that up to you guys at that point. But if you find by Friday that it's not going great for you and you would prefer us to do like 2 days of review, I certainly can do that. So, but that's kind of our goal for the week is to be done with the unit by Friday if we can. Today, we're going to talk about all the different properties with definite integrals. And they're not necessarily difficult so much. It's going to take us a little bit of time to go through it, so this wasn't something I could really rush, just because there's a lot of properties. But in terms of difficulty, you'll probably find today's is not too bad. There's just a bunch of little things we'll kind of talk about. Okay, so first property. First property. That's not a line. The first property is that if we have, whoops, all right, whatever. There we go. The first property is that if you are finding the definite integral from, say, a to b to c, if your definite integral lies above the x-axis, the answer to that definite integral would be positive. So I don't want to use the word area, even though area is probably easiest to understand. But the fact that area can't be, let me do that a different color. The fact that area can't be negative, okay? So what usually happens is that you'll find that the term area is kind of used loosely on a lot of this, and is often replaced with just the term the definite integral. So if I were to evaluate the definite integral from a to b, my answer would be positive because my function is above the x-axis. If I were to evaluate the integral from b to c, my answer would be negative because it's below the x-axis. So this is the first property. So that's why I'll try to avoid saying area, but it's just almost like out of habit that I say area a lot of times. But your answer to the definite integral above would be positive if your definite integral below is negative. I don't know, maybe I'll just keep scrolling down, I guess. Second property. And absolutely holler out and ask any questions. If something I'm writing down doesn't make sense, you guys aren't always great at kind of saying things out loud, you know, for fear of, I don't know. I'm assuming you just don't want to seem embarrassed, but remember, you can feel free to write questions in the chat, or you can put them on the Padlet if you want them anonymous. So just definitely ask questions, because if some of this is seemingly confusing to you, it's kind of a big deal that you get it answered. Okay, so now this one is the definite integral from a to a, so the same number. If we think about the answer as area, okay, if I'm integrating from one number to the same number, so this is definite integral of a point. Does anybody, how should I say this? I don't know if I want to call on somebody, but can anybody explain why they think the answer would be 0? Like, kind of in your own words? Sure, that definitely is a good way of explaining it. Yeah, you'd basically have a rectangle that would have 0 width, so your width and your height would still make 0. Basically, if you're trying to find the area under the curve, this is basically saying that you're going nowhere. So if you go nowhere, it doesn't matter what number this is, the answer should be 0. If the two numbers are the same, the answer would be 0. Yeah, nice job, Aiden. Third property. The integral from a to b of k times f of x dx is going to be equal to k times the integral of a to b f of x dx. Now, we've had similar properties to this before. Probably the most similar would be in limits. Basically, k has to be a constant multiplier. It cannot be a variable. So it would be a number, right? So sometimes it's called a scalar multiplier. But basically, if this is a number, like 5, so if you have 5 times a function, you can pull that 5 multiplier out and do the multiplier later. And sometimes that's useful to us. 100% as we go forward and get to complicated problems, this becomes really useful because we kind of take advantage of this property to make a problem easier for us to understand. Fourth property. This one we're going to use quite a bit today. And I actually kind of discussed this on Friday, but I didn't directly say it. What this one says, if you have the integral from any two numbers, so 3 to 5, if you reverse those numbers, so 5 to 3, basically, you know, whatever, just if these numbers are reversed, the answer would be the opposite. Now, I say I brought that up on Friday, and I'll just kind of erase this quick. If you guys remember, when we were doing area under the curve with geometric shapes, I brought up the fact that if we go to the left, the answer would be negative. This is basically the property that kind of applies to that. Traditionally, you write the smaller number on the bottom, the larger number on top. But if, for some reason, it's the other way around, where the larger number is on the bottom, smaller on top, well, your answer is going to be the opposite of kind of evaluating it the different way. That's basically the only thing you need to get out of this property, is that if these two numbers are reversed, the answer is made opposite. And I guess I haven't been writing little notes next to it, but that definitely is a smart plan if you guys do that. So like the kind of the plain words thing that I just said, if your numbers are reversed, your answer is the opposite. Fifth property. This one's just kind of a, yeah, it'll be helpful, but it's not a really big deal. Basically, if you find it advantageous to separate the terms of a function, you can. So rather than having a whole function together, you can evaluate them separately if you find that easier or helpful. So a lot of these are similar to the limit properties that we had. The sixth property may not seem like a big deal, but is actually going to get used a lot in different ways. The idea behind this one is the one that will help us. I screwed that up already. It bothers me a lot that they put the letter C in between A and B, but that's what this one is. I'll draw this one out for you to just show it. What the sixth property is saying is that if you are evaluating from A to C and from C to B, that it's equal to the integral from A to B. Basically, if you have two adjacent sections, you can evaluate them as one. That's what this property is saying. And it would have to be adjacent, like actually touching each other. And you'll be able to see this in all sorts of different ways. I know the examples I saw in Khan Academy frequently basically drew it like this, where you would have the first integral be above the axis, the second integral be below the axis, and it's equal to both of them put together. So that's how I frequently saw it in Khan Academy, but it 100% does not have to be like that at all. It can just be whatever. As long as you have two sections that are right next to each other. Sorry. If you have two sections that are right next to each other, you can evaluate them as one. I don't know. Anything you guys have on any of these six? You're being awfully silent today. Is it because these are not necessarily difficult yet, or maybe you just don't even know what to ask because they don't have, we're not doing examples? Because we can definitely just start doing problems together now. So seeing properties sometimes, may not make it click, but doing examples together might help. Are you guys really tired today? Okay. You guys definitely must be really tired today. So first thing, I'm going to apply some of these properties to what we did on Friday. So Friday was the fundamental theorem of calc. And it was when you do the derivative of an integral. I'm assuming you want me to quickly give you a refresher what we did Friday. Friday was the derivative of a definite integral where, you had something like this. The derivative and the integral symbol cancel each other out, and you're going to take whatever this variable is and put it in place of all of the variables there, remembering to multiply by the derivative of what you put in. So that should be kind of your quick refresher from Friday. I want to tie it into today's properties. Whether you noticed it or not, every single example we did Friday, we made sure that the variable was the top information. Well, if your variable information isn't on the top, so, I have an 8 on both. The number itself still doesn't matter. We want to be able to tie this into what we're doing today with properties. So the way you guys were taught this thing works was the variable information was on the top. It may confuse you to have the variable information on the bottom. Let's go with Sam. Sam, how could I flip these two around so that variable would be on the top? Do you remember what happens? What happens if I flip this information? Yeah, perfect. So what's going to happen is your answer is going to be negative from the other one. So if you switch the two A and B's, the intervals, whatever you want to say them, everything else works the same, except when you're done, the answer is negative. So I'm still going to take that variable information and put it in place of the variable. Nice job, Sam. Nice. Bella, go ahead. So I'll answer this just because I'm trying to follow the order that AP and Khan Academy teach this. We haven't done definite integrals yet. What's going to happen is when you evaluate a definite integral, the capital F is like the integrated answer. You plug in the top number minus the bottom number. Okay? And if we take the derivative of the integral, it's essentially doing the derivative of these. Now, if one of these two is a number, the derivative of a number is 0. So, kind of the quick short answer is we don't care about the number because when you're doing derivatives, the derivative of a constant is 0. It seems strange that the number itself is unimportant, but that's actually what ends up happening. So I guess it wasn't that short of an answer, but that's basically why. How are we doing on this example that I put up here, though? Oh, right, I almost forgot to actually write it in the answer. Now, see, part of the reason I don't like teaching this before we learn evaluation is because, to me, no, I don't want to screw you guys up. I'll show it to you again afterwards. Then it might make 100% more sense. Third example. If we are asked to take the derivative of an integral, and there's variable information on both spots, we have to try to figure out what to do with this. Now there's a couple ways that we can do this. One way is we can split it up. And I know that's the way that this is intended to be shown. So we're going to use this sixth property, and we're going to pretend that we have this answer, and we're going to go backwards and break it up into two smaller ones. So what we're going to do is we're going to pick a value that's in between square root of x and x squared. And we're going to break this up and say the integral from square root of x to a plus the integral from a to x squared. So we basically said that rather than viewing this as a whole integral, we can break it up into two smaller parts, two smaller integrals, by choosing a random number in between the two. And so we kind of took the one property and went backwards. Now this second integral, the derivative and integral symbol cancel each other out. We're going to put the x squared in place of t. So your answer would be x squared squared times the derivative of x squared. And this first integral because my variable information is on the bottom, I'm going to reverse these and make it negative. And then I'm going to plug square root of x in place of t. Times the derivative of square root of x. And then that would be my answer. Now obviously this one's got a lot more information than the other two examples. But I'm basically just trying to show you how we're going to tie in some of these properties. And that's kind of why it's important for us to learn the properties, because it allows us to manipulate integrals to be able to change them into things that we would be able to do. Now was this problem okay? Or is there parts of this problem that maybe you'd like me to go over where I got the answer from? Anything. I'm going to tell you that most of the problems you're going to get today are going to feel a million times easier than this. And that's why I kind of want to know how this one went. Okay. Yeah, honestly, it works great if you guys just put, little comments in the chat to say how you're doing if you don't want to speak up out loud. Okay. Okay. Well, this is the most difficult part of today, to be honest. Everything else you'll find really easy. This is the most difficult part by far, because the fundamental theorem of calc isn't like a super ridiculously easy topic for a lot of people. So if this felt okay, that's good. Honestly, today my guess is you'll have probably not quite a half hour to work, but you'll definitely have time to work today. Okay, so here's a common example. So you're given a picture. Often, I will tell you, often the number below the x-axis will not be written as negative. It'll just be written as a number. On the AP test, they frequently will write areas as variables rather than numbers. So these examples, there's numbers, so it's easier to follow and easier to learn. But once you understand an idea, do know that on the AP test, they basically just kind of give general things. Okay, so the integral from -2 to 0. So I'm going to start at -2, go to 0. Well, that's not super helpful because I don't know this answer. Okay, so integral from -2 to 0 plus the integral from 0 to 3. So I basically have two sections that I am trying to find the answer for, but they are adjacent to each other, and I know the answer for this whole section. So this particular example, what I can do is find the integral from -2 to 3 and put them together, so combined them. So my answer for this one would be 7, because that's the, I was going to say area again, that's the definite integral from -2 to 3. Basically just knowing that above the x-axis is positive, below is negative. Most of these questions you're going to get today are actually going to go very fast because they're basically just kind of looking at pictures and, you know, understanding what you're looking at. Okay, here's another example. I should probably call on people because all this silence is killing me. Chidera? Chidera, can you read off the problem we're asked to find? Maybe that's super easy, maybe it's not, I don't know. But can you read off what we're supposed to do? Okay, so the integral from 0 to 5 of -2 times f of x dx, yes. Okay, does anything stand out in there to you that we can work with or do? Okay, what about this -2? So that's considered a multiplier. Okay, yep, nope, correct. So what I can do is I can take -2 out, and I can evaluate the integral from 0 to 5 of f of x. Okay, do you want to keep going, Chidera, or do you want me to call on somebody else? Okay, how do I find the integral from 0 to 5 from this picture? Okay, perfect, perfect, correct. Correct. Once you kind of get used to these properties and, you know, are used to working with them, they go very fast. There's not much to them. That was a nice job. Anybody else have any kind of questions on maybe something we put up here? Okay. Trying to think who I haven't called in. Lauren? I don't know if I've called on you for a while. Do you think you could help me with this one? Sure. Yep. No, there's tons of ways you can say it, but honestly, when you first just said that that's the property, that's a very good explanation on its own. So, doesn't matter what number this is. If you're doing the integral from the same number to the same number, the answer is 0 automatically. Even if this is like the craziest picture ever, the answer is 0. Very good. I think I have one more. Or did I already put that up? No, I have one more. One more from a picture. I've got 2 other examples we can try as well, but so this one's just from a picture. Carson. Carson, was that you that told me to try the drive-by truckers? I still got it on my Post-it note. I think that was you. They were all right. Yeah, they were all right. Definitely more country than I was expecting. Okay, so anyway, I know I totally off topic there. How about this one? Any thoughts from you on whatever? Okay, how come? Okay, very good, but close. So I'm going to ask you how come the answer is -2. Yeah. Yeah, so it's really easy to skip this part. So these pictures are always going to depict the answers if you go from left to right. And so the smaller number is traditionally on the bottom because that's how you kind of read from left to right. So if they are reversed, then you just make the answer reversed. It's going to be really easy to miss that. But perfect. Perfect explanation. Alexandre, do you think you can help me with this one? I can make it bigger if it's hard to read that. I don't know. Anything. Okay. Okay. Like that. Is that kind of what you meant? Okay. What about the... Good. Okay, perfect. So 3 times -2. And then subtract 2 times 5. Perfect. So -6 minus 10, -16. Very good. I thought I would just try to give you this question without saying anything about it. And what you guys are going to find is pretty soon you'll be able to do a lot of these just directly in your head. Once you're used to the properties, and once they don't, make you anxious or stressed out, a lot of times you can just use them by just looking directly at them. Sydney? Sydney, how about this one? And this is the one that usually will catch some people off guard. Oh, and maybe your mic's not working right today. Who else have I called? Anthony. I don't think I've called on you for a while. How about this? Any thoughts on this one? Otherwise, I can kind of guide you and lead you through this one too if you want. I certainly can. So when I'm looking at the question asked, the question says, what's the integral from -3 to 5? Okay. But when I'm looking up here, that's not any of the answers given. Oh, that's no problem, Anthony. So, what I do notice is that I do have -3 to 5, but in separate ones. So a lot of times what I have to do is I have to write these out to keep them straight just because it's hard for me to picture these in my head. Given that I don't have an actual picture, I usually have a really hard time visualizing these. So I often will write them out kind of like this. And so when I write them like this, and obviously this is like ridiculously bad math notation, and we're going to pretend that I'm not showing you this bad math notation. But this is how I write it so that it's easier for me to picture it. So -3 to 1 plus 1 to 5, I could kind of like combine together because 1 is in between them and make the integral from -3 to 5 together. So for this one, you're told this answer is 6, you're told this answer is 8, and then you're asked to find this answer. So it would be 14. Now, this is an easier version of the problem. Where this gets confusing, and maybe I'll make one up on my own. Okay, where's my marker? You know what, I forgot the dx on all of them. Oh well. Does anybody think they could help me out with this one? This is actually more what the AP question would be like. For whatever reason, they try to phrase them differently or frame them differently, however you want to phrase it. Does anybody feel like they can kind of set this one up? Okay, so you may be correct, and maybe what I should have done is made one of these worse. Not worse, but like -6 or something, right? Where a lot of people get stuck on this one is they get confused as to which order you're supposed to subtract them. So what you're saying is absolutely correct, though. What I'm going to recommend you guys do is you use my really bad math notation. And I'm going to kind of like look at the numbers that are available. And the smallest number is -2. The biggest number is 3. So what I'm going to kind of do is I'm going to kind of arrange them in order from smallest to biggest. And then the third one be combined. And then the only reason I'm going to kind of arrange them like this is so I can kind of just place things in the correct spot. So -2 to 0 is the one I don't know, so that's kind of like the X or the question mark. 0 to 3 I was told. -2 to 3 I was told. And so I do subtract them, but to help you guys know which order to subtract, I'd recommend setting them up like this. So it would actually be -6 minus 8. Or it would have been -2 if I would have left it as +6. Okay, I don't know. This is about as difficult as the property questions get. I wanted to make sure to show you like the AP version here, this last one. Otherwise, these screenshots that I took are basically the exact questions that you will be asked in your homework and on the test. So those are the property questions. So I did skip one topic today because I didn't feel the need to teach it to you again. So the first topic on your homework tonight is definite integrals using geometric area. And we basically did that already. So I don't know. I'm not really sure why it was considered separate. The only thing I can think why this was considered a separate homework was because they added other geometric shapes like semicircles and whatever. But it's the exact same idea, so I didn't really feel like taking the time today to teach it because we already did. The second topic was properties. Shoot, I wrote it on Schoology. I'm drawing a mind blank here. I know that there are 3 assignments. I'm just gonna read it like this. I know that the properties were somehow separated, and I can't think in my head how they had them separated again. But the 3 homework assignments are what we covered today and Friday, and then you guys would be able to finish quiz 2 as well. So these are the 4 assignments I'd like you guys to get through, and this will definitely make us easily on pace to finish by Friday. So you guys have, I guess, 17 minutes left today. Unless you guys, want to stay and have questions for me on something, I can certainly answer some questions. Otherwise, this is basically it for today. Appreciate you guys coming. Make sure to take attendance if you haven't yet. I'll see you tomorrow. You're welcome. Yeah.